Hi, I'm Mitch Winger. Welcome to this video on a brief intro to data mining. I hope you enjoy. Okay, let's jump into it then. One of the first things we want to explore is the whole notion of cause and effect. So we've got correlation, and correlation is something that we've looked at many times. You looked at it probably in your stats courses, business stats, maybe other math courses you've had. You've taken a look at them in some other courses, accounting or other business coursework as well. So the idea is, what causes business success? What causes a lack of business success? Why do some succeed? Why do some fail? How can we determine, based on measures or other types of indicators that we can find, what's going to happen? And of course, this is the basis of a lot of business research. So this is one of the most unstructured problems that actually exists. We as humans like to believe that we understand patterns of events. And as a matter of fact, our brains are actually hardwired to recognize patterns quickly, even if they don't really exist. So you and I will see something happen once or twice or two or three times, and all of a sudden we say, well, that's the way it is. And as it turns out, this was a pretty good survival technique back in the day. Ooh, two other people from our settlement ate a berry from that bush and they died. And maybe I'd better not eat a berry from that bush. That looks like a pattern to me. And same thing with hunting and harvesting and things like that. So it was a good survival technique back in the day, but it just does not apply as well to complicated behaviors. So the more complex behaviors we have, and certainly in today's world, we've always had complex social behaviors, but our pattern recognizing brains still jump to conclusions right away. That's just something that's maybe instinctual to us. So we might see a simple correlation or a simple coincidence and ascribe causality. In fact, there's a whole website devoted to such spurious correlations. Let's take a real quick look here if I can find it real fast. Yeah, so this guy here has put together a lot of interesting charts, factoids, and so forth, and you can look and see at, he just has a bunch of them listed right off. Here's U.S. spending on science, space, and tech, correlated with suicides by hanging, strangulation, suffocation. Okay. Looks like a pretty good match. Here's one, people drowning by falling into a pool versus films Nick Cage appeared in. I don't know if you're a Nick Cage fan or not, but certainly something jumps out at you there. Cheese consumption and getting tangled in your bed sheets. Divorce rate and consumption of margarine. Age of Miss America and murders so a lot of death and destruction in these particular data correlations. It could just be the availability of crime data sets versus other types of data sets. Arcade revenues versus computer science doctorates. Well, that one may actually make sense. Who knows? There could be something to that one. Non-commercial space launches and sociology doctorates. And so on and so forth. Another one with cheese. So cheese stats must be easy to get your hands on as well. So as we know, correlation is not necessarily causation. So the problem becomes, do we rely on such anecdotal evidence from our previous experiences, one or two mentors that we may have developed? Do we rely on the experiences told to us by 10 colleagues or maybe 100 people that we know? Or do we use vast amounts of data that can help us find connections and reach conclusions? So you've probably learned in the past when studying the scientific method in school that we try to establish causality with randomized experimental treatments. We've got different treatments with different groups, and we might call the data generated from these types of experiments primary data. So we've got our primary findings that we've been able to develop from these, but in data analytics, we often take such data that's been used for one purpose, and then we repurpose it. We try and find secondary collections or use this data for secondary purposes. We'll call it secondary data that allows us to find additional relationships that we may not have seen or even been looking for with the primary experiment. So we find this with a lot of data that we can get our hands on. We can't necessarily prove causality in an experimental sense with this secondary data. However, we're still going to imply causality. We're going to use inductive logic to imply some causality, and we're going to have to use a lot of tools to be able to get there. We're going to certainly utilize the correlations and relationships between data elements that we find, but we're also going to have to post hoc theorize against it. We're going to have to develop some explanations and just use our own business and common sense to help explain why this might be or actually is a causal relationship. So the idea is, especially those that correlate with the outcomes we're looking for, such as a customer purchasing something, or a patient being healed, or a fraudulent transaction being found. So identifying a high correlation obviously is not the same as establishing a cause, but we're going to use all of our tools at hand to come up with that implication. All right? So data mining, if you will, is a process, and we're actually going to look at a methodology related to this process. So it includes collecting, aggregating, visualizing the data, coming up with relationships that we can make use of. You'll see tools like Tableau, Power BI used, including additional greater tools with greater analytic capabilities as well. Adobe Analytics fits in there. We use our traditional database tools, SQL for queries. We use tools to clean and aggregate the data. We use tools like Hadoop and MapReduce to evaluate unstructured data. So we've got all these types of tools available. Now, artificial intelligence, you can see it overlaps with data mining, but isn't exactly the same as or even a subset of data mining. So we've got artificial intelligence that includes logic. It's generally a computer program that tries to replicate our reasoning process, the way we logically approach things and make decisions. So in general, we start with some data mining, but it's not necessary. It doesn't always require a data mining process, so we could have some kind of an optimization formula. If you've used Solver in Excel, you could use that kind of an approach, or you could use an expert system where you have diagnoses that are developed, protocols that are developed by physicians, for example, and incorporated into an AI mechanism. So here we have a lot of overlap, but not a complete subset. And then finally, we have machine learning, which ends up being a subset of both of these. And it always requires a data set to come to some kind of a decision. One of the things that machine learning does utilize is once the model is built, it can use additional data to continue to train and update the model. So the predictive output is used to make a decision, and then the result is automatically updated, especially in those cases where the result is found right away. So machine learning tools, there are a lot of those. We're going to use one of them called Azure Machine Learning Studio. There's also Amazon Web Services, Machine Learning, RapidMiner, NIME, etc. So, and then you can also actually code machine learning directly into your data analysis languages like Python, R, Julia, and the like. All right, so when it comes to data analytics versus machine learning, obviously these two terms are closely related, In both, we're going to try and develop and uncover algorithms that help us understand the nature of some phenomenon of interest that we're looking for, some kind of an outcome that we're hoping to achieve some value from. And we may find that different attributes or different variables help us determine that result more or less. Age, income, experience, things like that. So from there, we try and imply some kind of cause and build our model. Now, in data analytics, we traditionally do this offline with data that we have harvested. There are a lot of reasons for that, including we don't want to disrupt the system in place. But unfortunately, with that approach, the model may eventually become stale. People's tastes change. We may have events that drive new needs and so forth. So one of the things machine learning does to kind of go above and beyond that is by constantly retraining the model with new data as it comes in. So machine learning allows the model to update itself as behaviors change. So why use offline data at all? Well, there are tons of reasons there. Let's look at a company like Amazon. They have more than 1.5 million transactions per day. If I wanted to try and use that live data and build a model from it, and run all kinds of complicated queries with it, test hundreds of different models with different parameters, well, I'm going to possibly utilize so many resources that I disrupt the processing of that operational database. And I don't want to bring the operational database down. I need that operational database because that's where I'm generating my customer revenues. So if I can pull some data out of it and take my time, analyze it, develop my understandings of what's taking place, develop my story, and then implement it in another fashion later on, that's what we do with the initial stages. So we need time to do that, evaluate those relationships, find the new ones that we didn't have any idea were there, figure out how to explain them, and decide whether we think they're useful from a causality standpoint, figure out which algorithm works best. And more these days, we have to consider societal aspects of the models that we put together. Are there issues that we need to be concerned with, or things that we need to say no and turn off because of societal implications, and then implement the model? One of the next things is descriptive versus predictive. Again, your first step in data analytics is you're going to try and understand or describe what's going on. So the descriptive techniques have been around for a while, starting with just plain old reporting. What happened? And we can use SQL queries for that. We can use report writers. Just about every ERP comes with a report writer that you can develop and build reports from. We can use search tools and things like that before. From there, we get into a little bit more analysis, and it's still kind of backward analysis. We're using pivot tables, we're using our OLAP tools, data visualization tools to figure out what has happened and maybe get a little bit more insight into it. One of the things as we keep moving along this spectrum, the methods of analysis are more and more valuable. So when pivot tables, OLAP, multidimensional analysis came along, people were like, wow, this is great. And we've moved on to additional things since then. Also, almost all of these tools in each subsequent level include the capabilities of the tools that were in the previous levels as well. So then we get into monitoring, putting together dashboards, KPI approaches, things like that we can start to monitor what's happening on a near real-time basis. And now we get into predictive techniques. How can we predict what's going to happen? We use predictive analytics. Regression is one that you're probably familiar with. Oh no, I misspelled it. Classification, clustering, forecasting, market basket analysis, textual analytics, and all those things we're using to help predict what might happen. Text in particular, we're using text to evaluate potential warranty claims and future product sales based on satisfaction, things like that. And of course, now we're getting into machine learning and artificial intelligence. We're adapting to those changes in more real time as user tastes change. So we can use machine learning to incorporate real-time input into our model and update the model as it goes along, rather than having to just every 3 months reevaluate, throw a new model in there and see how we can improve things. And we've got the usual culprits there as far as the vendors go: RapidMiner, Nime, Alteryx, from a desktop, and also from an online aspect, Amazon Web Services, Azure Machine Learning Studio. Those are the two dominant machine learning tools out there right now that companies are using. But we have all kinds of new platforms coming from vendors, large vendors like SAP, and small startups as well. So lots of stuff coming. We're still kind of boiling the soup and seeing what it turns into. So we've got different types of information, and we've alluded to that already. We've got the transactional information that sits in the operational databases. And it's important to recognize that operational databases, especially the customer-facing side of those, are crucial, are mission critical for businesses. They can't afford to let them go down. So we typically don't want to use those for resource-intensive analysis. So that's why we create our analytical databases that contain the analytic information. They actually restructure the data as well. So we've got the transactional information at low levels of detail, and the databases are designed using normalization to reduce the number of redundancies, data redundancies in the database as much as possible. And we actually reverse that process when we build these analytical databases. We add redundancies, we add summarization levels as needed, pre-calculate different totals and maybe even ratios for quick retrieval, but we'll leave some that may not be used as often for on-the-fly calculation. If you try and calculate every intersection of multidimensional data, you will end up with data explosion. We've tried that in the past with some early OLAP databases my company built, and we found that our database would explode from maybe 1 million or 2 transactions up, and it would we basically blow out the database with billions of transactions. All right, so that kind of leads us, and we've been talking a little bit about this, to what we call the tech stack for data mining. And there's always, that's a common term you'll hear in technology. What's your stack? Kind of the platform of different tools you're using to accomplish a goal. And for data mining and machine learning, we've got the data sources that we're used to. These are going to be our ERPs, other in-house systems that companies have put together. Companies have also learned to leverage lots of other sources of good data that they can use as well. Signet Bank even went so far, and lots of other companies are going so far as to create their own data at great cost. Or you can engage research or consulting firms to do that type of work for you. Web, phone surveys, information might be shared by business partners, especially those in your supply chain. We're seeing that more and more with the extended ERP. Third, databases. You can think of credit reports, media ratings from Nielsen for TV, radio, internet. Nielsen also supplies retail data to retailers so they can see what their competitors are doing, what's selling, and so forth. The U.S. Post Office sells access to address information so that you can fill in details. And actually, for large companies that do send out mailings, you can save money by having more complete addresses and then the fully articulated 9-digit zip code and so forth. Extract, transform, and load. Well, before we get there, let's take a look at those data lakes. So data lakes are relatively new. You're not going to see all companies with them, but again, these are going to be data stores that you may just dump the ERP right in there, as well as a bunch of other data sources, email, Twitter feeds, and so forth. So you're going to have lots of different data in lots of different formats, and we're seeing that more and more. And you can see in that middle option that some companies are opting to extract directly from the data lake into their end user presentation and analytic tools. We're not seeing a lot of that yet. For the most part, you see something a little more like you see on the left or the right, where you're going to do a little ETL and move things into a data warehouse, either directly from the data sources like you see on the left, or from the data lake like you see on the right. And then you and I, for the most part, the business analysts, unless you get involved in your data analytics team, core team at your firm, you'll probably interact with this data mostly from that end user presentation standpoint. Okay, so ETL, we've got extract, transform, and load. The transformation, in general, I'm going to argue a little bit with the author of this text and say you generally do not summarize too much, if at all, in your data warehouse. You leave all of the detailed transactions there. You want the data to be as atomic. You want access to the data at the lowest level of what we call atomicity. You want the lowest level of atomic data you can, not just the journal entry totals, but each line item in that journal entry, or whatever other transaction you're looking at. In the warehouse, when the warehouse is built, you're going to choose a number of summarizations and other calculations to make. You might even try and normalize some of the data, or log some of the data, log convert some of the data. But then the warehouse is available for additional analysis. So the ETL, the transform, includes all those calculations. It includes maybe any data scrubbing or data completion, data exclusion that you may need for missing data. In general, you'd save that for the analysis portion rather than in the warehouse portion. And also, you're going to have different definitions from different data sources sometimes that you need to rectify. All right. So the data lakes we've talked about, the data warehouse we've talked about, it's going to be unnormalized. So we've got that star schema or snowflake schema that we're going to be using. And then those presentation tools at the end, Power BI, Tableau, SQL query tools, Amazon Web Services Machine Learning, Azure Machine Learning Studio, Alteryx, Excel, RapidMiner, KNIME, you name it. All right. So that's a brief overview of the data mining environment. Hope you found this video useful.